Hi everyone, we are Team 2, consisting of Inkai, Crystal, Krishna, Hugo, Singh, and Ikshong. Today, we will be presenting a fun demonstration on the Bernoulli equation and discharge. We hope that you enjoy this experiment as much as we had fun making it. Have you ever wondered what is the fastest way to empty a bottle? Well, today we'll be showing you the secret technique that few have mastered. For the purpose of this experiment, we'll be using a constant volume of water and maintaining a relatively constant height of elevation. Now comes the fun part. Make your guess on which way we'll empty the bottle out first. 1. Inverting a bottle and emptying out normally. 2. Blowing on a straw. 3. Creating a vortex in the bottle.
Which of these three methods will empty the bottle the fastest?
Alright, let's find out which way we'll empty the bottle out the fastest.
Go.
Since both the surface of the water and the water escaping through the hole are uncontained and exposed to the atmosphere, we can assume that the pressure at the top of the liquid and the liquid at the mouth of the bottle are at atmospheric pressure and are equal. Therefore, they can be subtracted from both sides and cancel each other out. Simplifying the Bernoulli equation, we can attribute the output velocity to the height of the water level and the force of gravity only. When perfectly vertical, the water flow creates a vacuum, on which atmospheric pressure intermittently pushes air upwards into the bottle, interrupting the water flow until it exceeds atmospheric pressure and resumes. This alternating stop and go motion hence results in this method taking the longest time among the three experiments.
Moving on, we tried emptying the bottle by applying a vortex as seen in a demonstration earlier, which we created by rotating the bottle in a swirling manner. When a vortex is formed due to the rotational forces acting on the bottle, the water is pulled downwards and forced towards the mouth. The speed of the water around the center increases as it approaches the center of the bottle, and as the water is deeper, the centripetal forces acting on it are greater due to the smaller radius and higher speed of the water flow, resulting in a lower internal pressure. Where the water pressure is lower, the air above the water pushes it out of the way, making a hole which allows air from the atmosphere to flow easily into the bottle. Since air is now able to enter the bottle, pressure at points 1 and 2 are equal, and unlike in the earlier method, vacuum does not form and the flow of water is not interrupted. Following Bernoulli's equation, the velocity of the water at point 2 will definitely be faster as compared to just emptying out the bottle normally.
Inserting the straw into the bottle before pouring out the water from the bottle gives air its own path into the bottle without disrupting the flow of water. When the water is drained by the force of gravity, a negative pressure vacuum region below the local atmospheric pressure of 0 is created at the upper part of the bottle. With the introduction of air continuously by blowing through the straw, the pressure at the negative pressure vacuum region will increase the local atmospheric pressure, which is 0, thus allowing more water to be drained. Using the Bernoulli equation, with a greater velocity at the opening of the bottle relative to the case where a straw is not used, its discharge will increase, which will reduce the time required to drain the bottle.
To conclude the presentation, let's compare the timings. The slowest was the normal way of emptying at 18.08 seconds, followed by the vortex method which took 7.18 seconds. The fastest was with the straw at 5.81 seconds. This table is a summary of the ideas to explain this phenomenon. For the units used, P1 represents the pressure at the top of the bottle, and P2 and V2 represents the pressure and velocity at the bottom respectively. Through the use of Bernoulli's equation, we realized that the difference in values for P1 and P2, otherwise known as the pressure gradient, is somewhat proportional to V2. For the normal way of emptying the bottle, the pressure gradient is negative, therefore it emptied the slowest. For the straw method, through the blowing of air into the top, P1 becomes larger than P2, and the pressure gradient is positive, resulting in the fastest discharge. So did y'all correctly guess which method will empty the bottle the fastest?